Hey guys, so this is our last lesson. We're graphing everything else. So we've graphed sine, we've graphed cosine. We know that there's a lot left. There's still tangent, cotangent, secant, cosecant. So we're gonna start with cosecant and secant. So we're gonna be using a lot of highlighters today. So if you wanna pause and get some highlighters out in case you don't have any in front of you, or if you don't have highlighters, markers work just fine too, or colored pencils or even a crayon. So I have my list going on right here, ready to go, okay? So we're gonna be graphing everything else. So in class, I would totally do this because I like to do that. Okay, I like to make my notes colorful, and you guys know that. All right, so part one, this has 3 parts to it, okay? Graphing cosecant and secant because they kind of go together. They follow the same sort of rules. My battery power is low, Nick, so I'm gonna need my charger, please. Okay, so anyways, so first of all, I wanna look at our steps. So we're gonna look at what we have here. So the first step is to graph the sine of theta or cosine of theta version. So you need to graph the sine or cosine wave first, whatever it is, okay? Then step 2, we're gonna identify where the wave crosses the x-axis, okay? So we wanna see, okay, where is it crossing the x? It's gonna be important, you'll see why. Step 3, we're gonna draw vertical asymptotes at the axis intercepts. So remember we would draw those dashed lines, these would be vertical asymptotes. Basically they're a border, they can't cross the border. Okay, you guys remember that from last semester when we did rationals? Yeah, and then step 4, we're gonna flip the waves, okay, in between the asymptotes, and you will have parabolas going up or down. So remember, parabolas are, you know, there's a parabola, there's a parabola. That's what we're gonna see. Okay, so example 1 is completely worked out, but let's go through what it entails. So we have y equals the cosecant 2 of x minus pi plus 1, okay? Well, it says since cosecant is the reciprocal of sine, we actually graph the sine version to get cosecant. Graph the sine version to get cosecant, okay? So step 1, my dogs are begging for treats. Actually dog, because Princess Leia is the one that barks for her treats. Yes, I just said Princess Leia. Anyways, step 1. So step 1 was in orange, so I'm gonna highlight that in orange. We graph y equals sine 2 x minus pi plus 1. And so, okay. So first of all, I have notated here that plus 1 means that the axis moves up 1, our midline moves up 1. So let's go ahead and mark that. There's our midline. It's up through y equals 1. Y equals the number is a horizontal line, okay? And so we know that, and then it was also shifted to the right pi. We have our start, we have our stop. So we know it's starting at pi, it's ending at 2 pi. This work is already done for us, okay? And then I would find the increments in the middle. So, but I'm not gonna go through all that, okay? So we're just gonna be like, okay, magically it gets, well, not magically, it took math. And some of you might think that math is magic sometimes because you're like, how do I get there? But anyways, here's our sine wave, okay? And so sine wave is graphed. Step 2, that's where this little bubble is pointing to. It says draw vertical asymptotes at the axis intercepts right here, under step 2. Identify where the wave crosses the x-axis. So I'm gonna highlight this. And we're crossing right here. Now notice how it says axis, but it doesn't say x-axis. Know why? X-axis is down here, but our midline moved it up 1, so now it's up here. So that's why it doesn't say x-axis, because sometimes it is, and sometimes it isn't. So, right. So it's crossing through the axis there, 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 and there. Okay? Step 3. Now we're drawing the vertical ones. Draw the vertical asymptotes at those axis intercepts. So where I drew that pink dot, I'm gonna have a vertical asymptote, also one right here, also one right here, also one right here. Okay? Oh, and also one right here. right, can you guys see that okay? All right, step 4, flip the waves. So when I say flip the waves, basically here's the sine wave right here in this between these first two asymptotes. And I see the wave there, so it got flipped. Okay, and then I see the wave here, and it got flipped. And I see the wave between these two asymptotes, and I flip it. And I see the wave between these two asymptotes, and I flip it. Okay? Pretty much. The flipped waves part is the graph. So I want to show you what that looks like on Desmos. So it's not going to look the greatest, because videoing your computer screen is always kind of, oh, it doesn't look pixelated. Huh. I wonder why sometimes it does and sometimes it doesn't. I am so new at this technology stuff when it comes to these things, guys, that I just don't know. Okay, so it was y equals any cosecant. So that's going to be under this, oh, you guys can't see. There we go. See my cursor's on functions, and I see cosecant. There it is. Oop, there it is. That used to be a song when I was in school. Anyways, it's cosecant. There's a 2 in front of the parentheses, so I'm going to put a 2 there. And then in the parentheses, it goes x minus, oh, did you guys see that? X minus pi, close parentheses, and then plus 1. So literally, the cosecant graph is all these flipped waves, these upward facing parabolas and downward facing parabolas. The sine wave is literally in between these waves where they were flipped. Yeah, so it would be going do 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 do. Yeah, anyways, probably not with the song attached, but yeah, so that's how it would go. Okay? All right. So now we are going to use this empty space down here. Let me zoom out a little bit so we can see it more. And we're going to have a pre-tangent example. So that was cosecant and secant. We're done with that. It's really easy. You graph the sine or the cosine graph, and then you flip the wave, and then you have the cosecant or secant graph. Super easy. Okay, for the pre-tangent example, that's what it's called. Pre-tangent example. Okay. We're going to do just like we did when we were showing you how to graph the sine and the cosine wave. We started off with a t-chart. All right, that's in my way. You got to go. And in that t-chart, of course, we have x and y values. And we used 0, pi over 2, pi, 3 pi over 2, 2 pi. And then we went in the negative direction, which would be clockwise, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Sorry, I got a tickle in my throat. I need to take a drink. Oh, it would help if my water cup was open. All right, sorry about that. Okay. Anyways, so when we were graphing sine and cosine, we had y equals sine of x, or y equals cosine of x. So we're graphing tangent, so y equals tan of x. And we need to remember something. We need to remember tangent is the same as sine of x divided by cosine of x. And remember when we're graphing, the x value is cosine, the y value is sine. Okay, so let's draw a circle. I'm actually really proud of that circle right now. And then, of course, we're going to have a graph. So try to make the graph in the middle. Okay. All right. And so we know we have 0, pi over 2, pi, 3 pi over 2, back around 2 pi. Okay. And we know that these coordinates are 1, 0, 0, 1, negative 1, 0, 0, negative 1, and then back to 1, 0. Okay? All right, so let's go ahead and plug these in. So remember, again, like I was saying, the x value is cosine, The y value is sine. Okay? So for tangent, to find the tangent, we would have to take the sine and divide it by the cosine. Okay? All right, so let's start with at 0. At 0 degrees, we are at the coordinate 1, 0. So 0 divided by 1 is 0. Okay? At pi over 2, we have the coordinate 0, 1, and sine divided by cosine, that's 1 divided by 0. We can't divide by 0. 0 makes it undefined, so this is undefined. I'm just going to put und, period. For pi, the coordinate is negative 1, 0. So sine over cosine would be tangent. So 0 divided by negative 1 is 0. And then at 3 pi over 2, sine divided by cosine would be negative 1 divided by 0. Oh, well, negative 1 divided by 0, anything divided by 0 is undefined. Okay, and then at 2 pi, we will have sine divided by cosine. So 0 divided by 1 is 0. And now we have to work our way in the negative direction. So negative pi over 2 is the same as 3 pi over 2. So that would be negative 1 divided by 0 to find the tangent, and that is undefined. Over at negative pi, 0 divided by negative 1 is 0. At negative 3 pi over 2, 1 divided by 0, undefined. You see the pattern here? And then from, so that was what, negative 3 pi over 2, then negative 2 pi, 0 divided by 1 is 0. So we're going 0, undefined, 0, undefined, 0, undefined, 0, undefined, all the way through. Okay, so when we go to graph this, this is what we're looking for. What color do I want to use? I'm going to use this color. Draw a graph. Okay. And so since this is the parent function, it hasn't been shifted left or right or anything, we'll have on here, let's see, we could fit in a pi over 2, pi, I don't have room for more on this side. I could also go in the negative direction, negative pi over 2, negative pi, negative 3 pi over 2. Okay. So let's start with the parts that are undefined. And I'm going to use, the highlighter has a fat tip on it, so I'm going to use this marker. So pick like a light neon or whatever, a light color. And at the undefined points, we're going to draw vertical asymptotes. So my first one will be at pi over 2, because we had it undefined at pi over 2. So at pi over 2, I'm going to draw a vertical asymptote. Okay. I also had one at positive 3 pi over 2, but I didn't have enough room for that, so that's okay. I'm going to skip it, and I don't have 2 pi either, but that one is not undefined. Negative pi over 2 is undefined. Negative 3 pi over 2 is undefined. So I'm basically going to have 2 cycles in this graph. That's all I could fit in here. Okay, so what you have to do is find what is exactly in the middle between those asymptotes. So let's start with these two. Between negative 3 pi over 2 and negative pi over 2, those are these two asymptotes. Directly in the middle is negative pi. So plot a point right there. And basically with tangent, you can fake it till you make it. Just hug the wall going up on the right and hug the wall going down on the left. Do the same thing over here. But halfway between, or in the middle, between negative pi over 2 and positive pi over 2 is the origin, 0, 0. Hug the wall going up on the right, hug the wall going down on the left. So pretty much, tangent looks like that all the way around. Excuse me. If you don't believe me, we could take it to Desmos. So put you back up here. Zoom in a tad. Y equals, I need tangent of x, and look at that. There is my tangent graph.
Can you see me?
I'm zooming out. Ooh, that could make you dizzy. Okay, back to the notes. All right, so here's some things. We have some main differences. So obviously with cosecant and secant and tangent, we have asymptotes. Okay, with cosecant and secant, you flip the waves. With not cotangent, this is tangent. With tangent, we have asymptotes also, but there's no amplitude. You know how sine and cosine have amplitude? Well, these don't have amplitude because these are going up to infinity or down to infinity. These are going up to infinity in each of those directions, upward and downward. Okay, so there's no amplitude because the graph goes to positive infinity and negative infinity. Okay, so those are the main differences between sine and cosine and the rest, pretty much. Okay, all right. So the next page is on graphing tangent. This is part 2. Okay. Normally I would teach this lesson. Well, for regular math 3, I'd probably break it up into 2 lessons, or I would try to do the whole thing. I have tried to do it in the past, but it is a long lesson. But anyways, part 2, graphing tangent. So we saw what the parent function looked like. Okay. Now we're going to see, okay, well, how does it work? How do we know where to put the asymptotes? Do I just guess? What do I do? Can I fake everything, or do I need to know certain parts of it? Well, you do need to know certain pieces of the puzzle for sure in order to fake it properly. Okay. Sorry, I need another drink. Try not to like gulp in the microphone, so I don't want you guys to hear that. I hate having to hear that. All right, tangent properties. Let's look at those first. So first of all, tangent has no amplitude. Okay. Second of all, it does have a period. Remember, for sine and cosine, the period was 2 pi over b. For tangent, it is just pi over b. Okay. Tangent obviously does have asymptotes, and this is how you can find where they go. With the parent function, it's easy because it's just every other one, pretty much. But when we get moved to the left or the right, this is where it changes where our asymptotes are going to go. So to find the asymptotes, you take the b times x minus c part and you set it equal to plus or minus pi over 2. Okay. And then we graph based on the asymptotes instead of start and stop. Okay. So the asymptotes are what drive us to be able to graph it. Okay. All right. So example 2 is also completely worked out, but we're going to go through what the steps are. So we have example number 2, y equals the tangent of x plus pi over 4. Okay. So first of all, when we make our list, because you still have to make your list for these, there is no amplitude. Okay. It's tangent. It goes up to infinity, down to infinity. It does not have an amplitude. It doesn't have a highest point or a lowest point. The period is pi over b. Well, the b is 1 here because that number in front of the parentheses is a 1. So this is pi over 1, which is just pi. So there is our period. Okay. This one does have a phase shift. Okay, because it says plus pi over 4. That means we are going to the left, to the left. Okay, left pi over 4. Pretty much we don't do anything with that, but you do need to be able to identify it. That's why it's important. Okay. There is no plus or minus a number after the parentheses, so that means that there is no vertical shift. There's none. Okay. So the mega big important piece are the asymptotes. And remember, we find the asymptotes by setting the b times x minus c part equal to plus or minus pi over 2. So this part. Okay? So here it is, x plus pi over 4 equals plus or minus pi over 2. Okay, so what we do here is we need to solve for x. So that means that we have to subtract pi over 4 from both sides. So minus pi over 4, minus pi over 4. Okay, and what we do is whenever we have a plus or minus involved, we like to take that term and put it in front. So it ends up being negative pi over 4 plus or minus pi over 2. Okay, we have to get a common denominator. So obviously they're both going to need to be a 4 because we can't make it go lower, but we can make the denominator go higher. So multiply top and bottom by 2. So here we go. It continues on right here. So we have negative pi over 4 plus or minus 2 pi over 4 because pi times 2, 2 times 2, okay? And now let's take care of the plus or the minus. So this one's the plus, this one's the minus. So negative 1 pi over 4 plus 2 pi over 4 is positive 1 pi over 4. Negative pi over 4 minus 2 pi over 4 is negative 3 pi over 4. Okay, here are our asymptotes. And that is where we're going to start. You always start the graph with the asymptotes because that's how you know where the tangent graph is. Okay, so let's start there. So this graph is already ready for me, okay? Now, since you're like, well, what about increments, Ms. Garcia? How do we know to put those increments there on the graph? Do we leave it blank? No, you don't leave it blank. If you leave it blank, I take points off. Please don't do that. Okay, so anywho, we have the pi over 4 tells you, okay? So basically what I like to do is count in increments of pi over 4 since that's the lowest fraction there. So 1 pi over 4, this line would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So I'm counting by pi over 4s and then also in the negative direction. So we have an asymptote at pi over 4. So that's right here. So I'm just going to trace over it with a dashed line. And we also have an asymptote at negative 3 pi over 4. Okay, so it's these two right here. I'll get to the rest of that later. Okay, and then it says, then halfway between the asymptotes, the graph crosses the x-axis. Okay, so halfway in the middle there, I'm going to plot a point, which ends up being at negative pi over 4. Okay, and then literally the next step is to fake it. Fake it till you make it. So we know, based on the parent function, that tangent hugs the wall going up on the right and hugs the wall going down on the left. Okay? When you're doing a tangent graph, having just this is not enough. You need to have at least 2 cycles. Okay? So, when we do another cycle, well, how far apart are these from one asymptote to another? They're 1, 2, 3, 4 spaces apart. So the next one would be 1, 2, 3, 4 spaces apart. So you just continue the pattern. These have patterns that we can predict. They're very predictable because they'll keep happening over and over and over again. They're cyclical. That means they have a continuous cycle. Okay? Obviously, I've not talked this much in a couple of days, so it was Mother's Day weekend, so I've actually been chilling, having fun. All right, so example 3 is another tangent example, okay? And we have y equals 1/2 tangent of x plus 1. But Mrs. Garcia, there's a 1/2 out front. What does that mean? It just means that the tangent wave, there's no amplitude, right? There's no amplitude with tangent. So it does not mean amplitude. It means that the tangent wave itself is getting compressed. Remember, fractions make it fatter, whole numbers make it skinnier. So that means that someone is sitting up here and squishing it. Like I was told when I sat on my bike today and my back tire went flat and someone asked me if I had gained weight and I was like, that was rude. But anyways, yeah, thank you, husband, best friend. That's how it goes. Anyways, so the amplitude is none, obviously, because it's tangent, so that's an automatic. The period is pi over b, but the b is just the coefficient on the x or the number in front of the parentheses. And it's just a 1, so just pi over 1, which is just a pi. And then there's no phase shift. There's no parentheses, so we're not moving left or right, so there is no phase shift. There is a vertical shift. So that means that our midline got moved. It got moved up 1. we have asymptotes. That's where we take the b times x minus c, which is just x this time, and you set it equal to plus or minus pi over 2. So hello, x is solved for, so you don't have to do anything else there. That one has the answer pretty much in it. Actually, it's not just pretty much in it. It is the answer for the asymptotes, okay? All right, so now let's go ahead. What do we do first? Yeah, we graph those asymptotes. So let's start with that. We have plus or minus pi over 2. So because the lowest fraction in our asymptotes is a pi over 2, that means my increments are in pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and so on in each direction, positive and negative. So we have plus or minus pi over 2, so we have a negative pi over 2, positive pi over 2, and this would be just one cycle. So I need one more cycle, remember? So it is 1, 2, well, I guess this would be 1 in here. Oh, shit, never mind. That's not a dash mark. Sorry, 1, 2, 1, 2. That's our next asymptote. Sorry, I was taking that 1 as a dash mark, but that's just 1 because that's at 1 on the y. Okay, so also remember when we're graphing the sine and cosine, we always mark where the midline is, and this time the midline moved up 1, and so it's not on the x-axis, it's up here through y equals 1. Lucas, stop. Okay, so now remember we have to find halfway between the asymptotes, and that's where it crosses the axis at. So that means that halfway between, we're going to have a crossing point here and a crossing point here. And then fake it till you make it. Hug the walls going up on the left, down on the right. 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 Okay? And there is another tangent graph. So really, all we have to remember with this one didn't have a number in front. It didn't have an a value. And remember, tangent doesn't have amplitude, but I do want to point this out, that this is a vertical shrink of the graph, like it was squished. Okay, when it's a whole number, it's a vertical stretch. Fractions, it's a vertical shrink. Same as with parabolas, same as with radicals, same as with cube roots, square roots. So yeah, fractions, vertical shrink, whole numbers, vertical stretch. All right, part 3. Cotangent. Makes me think of the way I said that, what is it called? Despicable Me. Lipstick taser. I don't know why it made me think of that, but that's what I thought. So anyways, part 3, we are graphing cotangent. Okay, well, why does cotangent have to be all by itself? Well, tangent was kind of all by itself, so cotangent will be too. They all have the same setup, pretty much. Same ABC going on. Oh, sorry, ABCD going on. Okay, let's look at our little bag of tricks over here. So again, well, if tangent has no amplitude, obviously cotangent is going to have no amplitude. The period is pi over b, just like tangent. Okay, that's easy. This is where things get a little tricky because the asymptote part is found differently. So to find the asymptotes, we set the b times x minus c part to plus or minus pi. So cotangent is plus or minus pi. Tangent is plus or minus pi over 2. Okay? And there's a little tiny trick with cotangent. There is a hidden asymptote halfway between these two asymptotes. Okay? And these asymptotes obviously are where cotangent is undefined. Remember, an asymptote is a spot on the graph where the graph is undefined, so that's why those barriers are there. Okay? And we also have to remember that cotangent is the reciprocal of tangent. So remember, tangent was sine over cosine, so cotangent is cosine over sine. All right, so let's take a look at this example. This is example 4, okay? All right, so we have that y equals 2 cotangent 2 of x plus pi, okay? So we have, this is our A value, this is our B value, this is our C value, but I'm just gonna say, okay, well, this is also our phase shift. So we know it's going to the left because it's plus, left pi. And there's obviously no D value, we're not going up or down. So that means that the midline did not move. It is going to stay the x-axis. Okay. So next is cotangent. There's no amplitude as we make our list and check it twice. It is not Christmas. Why did I say that? Anyways, pi over b. The b value is this 2, so pi over 2. Can't reduce that, so the period is pi over 2. And then the phase shift, I did say it was to the left. It is to the left pi. So we're scooching this graph over to the left. There's no plus or minus a number after the parentheses, so there is no vertical shift. Okay. So let's find the asymptotes. Well, they're already found, but let's go through it. So this is where we take the b times x minus c and set it equal to plus or minus pi. So I'm going to switch colors here. The b times x minus c is this part, the 2 times x plus pi. So see, they took that and they set it equal to plus or minus pi. And notice that there's this reminder, there is a hidden asymptote in between these two that we're going to find. Okay. So we need to remember that. So cotangent has a hidden one. All right, so notice, remember how I said before, don't distribute the number out front? Keep doing that, don't distribute. So what we gotta do is we have to divide both sides by 2, and we get x plus pi equals plus or minus pi over 2. Subtract pi from both sides. Remember to put it in front of the plus or minus. You have to get a common denominator. It's going to have to be a 2, so we have to multiply top and bottom by 2. So that becomes negative 2 pi over 2 plus or minus pi over 2. And then when we do the plus or minus, negative 2 pi over 2 plus 1 pi over 2 is a negative pi over 2. It's this one. And then when we do the minus, negative 2 pi over 2 minus 1 pi over 2 is negative 3 pi over 2. But let's not forget, there is a hidden asymptote in between these two, okay? All right, so remember, when we are graphing these, we have to start with the asymptotes. So for tangent and cotangent, you always start with the asymptotes. With secant and cosecant, you start with the sine or cosine graph and then flip the waves. Okay, so remember, we always start here. So since it's basically going in pi over 2s, that's how I want to increment my graph. And since these are the negative side, I'm going to, obviously the negative side was focused on, okay? So we have an asymptote at negative pi over 2, so that's the one right here. And so it goes negative pi over 2, so that's negative 1 pi over 2, negative 2 pi over 2 reduces to negative pi. Negative 3 pi over 2, negative 4 pi over 2, which would reduce to negative 2 pi, and so on and so forth. Okay, the other one was negative 3 pi over 2. And see, if you didn't remember that there's a hidden one in the middle, you might graph this as just one cycle, but there's really 2 cycles in there, okay, obviously. And hopefully you notice something else going on here that's a difference between cotangent and tangent. All right, so you also have to find the hidden one. It's halfway between. So this is 1, 2, 3, 4 spaces apart. So 1, 2 would be in the middle right here. So we have an asymptote right here. Okay, this is the hidden one. Okay, and then you basically fake it till you make it from this point. When you do it, though, cotangent obviously is a reciprocal of tangent, so that means we have to flip the tangent. So when we do that, it now hugs the wall on the left going up and on the right going down. So plotted in the middle, on the left going up, on the right going down. Okay. And what's nice about that is that I don't have to come up with an extra cycle. I already have the 2 cycles right here, 1, 2. So that's what's nice about that, okay? All right, so on the next page, was there a 4th page? There was a 4th page, and I must not have printed it, or I didn't grab it accidentally. So here it is. Okay, this is your asymptotes guide, and it's going to come in handy when you're trying to remember what. But you know what? When you guys take your test, it's open book, open notes. So if you need a reminder, keep your notes out in front of you, and then they're right there. Okay, and then you won't be tempted to use Google. You won't need to. You'll know exactly what you need based on the notes that we took. Okay. All right. So it says the asymptotes only apply to functions that are undefined for certain x values. Okay. So the ones where we get x values that are undefined are cosecant, secant, tangent, and cotangent. Basically, all the ones that have fractions. Because if you have a fraction, potentially you could have a 0 in the denominator. Okay. Especially if sine is 0 or cosine is 0. Right? Because secant is 1 over cosine, cosecant is 1 over sine. All right, you will always have to set b times x minus c equal to plus or minus wherever it's undefined, wherever you get a 0 in the denominator of a fraction. So for tangent, you take the b times x minus c and you set it equal to plus or minus pi over 2 because cosine would be in the denominator and cosine is undefined at pi over 2 and negative pi over 2. Pi over 2 going counterclockwise, negative pi over 2 going clockwise. Counterclockwise? Clockwise. Cotangent is the kind of opposite. It's not exactly opposite. It has a hidden one, and you set the b times x minus c equal to plus or minus pi. Okay? And that's because cotangent is cosine over sine, so sine's in the denominator now. And when sine is 0, that's at these 2 points, 1, 0 and negative 1, 0. So that means at 0 or 2 pi and negative pi. Okay? So that's why you set it to plus or minus pi. Cosecant has the same kind of things going on as cotangent. Now, you don't really necessarily need an asymptotes guide on cosecant because as long as you are graphing sine, you know where to flip the waves. You know where the asymptotes are, okay? Same with secant, but secant follows along the same lines as tangent. So you can use that to help you figure out where exactly the asymptotes are, but if you graph the sine or cosine graph correctly, you'll be able to tell where they are without doing this extra work. So you don't really need to know that the cosecant and secant have asymptotes at plus or minus pi and plus or minus pi over 2 when you set the b times x minus c equal to it. But, I mean, it's true, so I have to give you that information. But you guys won't really need to use those. The two that you are going to need to use the most are tangent and cotangent. So those ones are the ones that you should focus on, but you don't have to memorize it because you get to use your notes. So you don't even need to worry about that. Now, if we were taking this in class, you would not be using your notes. So you lucky dogs. I'm just kidding. But yeah, you're really lucky. You get to use your notes on this and you have all the resources that you need. You don't need anything else. Okay? All right, so your homework is, where's the homework page? This other attachment, it's linked under the assignment in Google Classroom. It's graphing tangent, cosecant, secant, and cotangent. You might need a piece of graph paper. If you don't, you can use line paper like I told you for sine and cosine. You're going to be doing all these problems. It's 11 problems, okay? And that's all it is. You're going to be graphing, you see we have tangent, 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 cosecant, cosecant, secant, cotangent, cotangent. You're going to review graphing just sine and cosine. And then you need to answer this question. How do you determine where the asymptotes go for tangent, cotangent, cosecant, and secant? And the answer to that question can be found in the asymptotes guide. Just saying. Okay? All right, so that's everything. I hope you guys have a good one. And this video actually wasn't that long. And go have a good one. Get your work done. Please try not to procrastinate this week, guys. We do have our test on Friday. It must be taken during, my testing window, which will be from 9 a.m. to 1 p.m. on Friday, the 15th. And if you miss that testing window, you will not be able to make up that test. So please plan accordingly and go have a good one. And I will see you guys in my next video.